We are live in 5, 4, 3, 2, 1. Let's do this. Welcome to the first virtual demo day live here at Haas Automation. Thank you all for joining us. It is really loud over here, isn't it? So we appreciate all of you taking a few minutes of your day to join us for this. This is obviously something new. Most of you are used to going to your local Haas factory outlet and seeing demos, talking to your HFO applications engineer and salespeople, and probably getting a really killer lunch. We're going to try to replicate all of that except for the lunch, obviously, here today. Thanks again for joining us. We really appreciate it. We're here at the Haas factory in Southern California, Oxnard, California to be exact, and we're going to have a couple of locations. One is here in Building 2. If you've ever been to the factory, we're just outside the products and training area. And then the remainder of it will be up front in the demo room, which a lot of you are familiar with if you've done tours here. So we're going to go over 4 machines today. We're going to start with the UMC 1500 Duo. John Nelson and I are going to talk about that. Then I'm going to throw it up to the demo room to Andrew Harnett, and he's going to cover the auto parts loader, or APL. He's going to start with the lathe. That's Andrew and Bob Singh. And then he'll move over to the mill with Milton Ramirez. When they're done with that, I'm going to be walking back to the demo room, and then Corey Sullivan and I are going to be talking about the Haas robot package. Now, real quickly, if you've noticed, I'm holding my mask here. Both John and I took our masks off because we're on camera, of course, but everybody here at Haas Automation in the factory wears a mask all day, every day. We're trying to keep everybody safe, of course, and we're trying to keep the factory open and be able to service and support our customers. So, thanks again for joining us. Let's jump right in. John, tell me a little about the UMC 1500 Duo.
So UMC 1500 Duo, really it's a perfect marriage between a UMC 750 and a VF2 YT. Essentially, we've got the 2-axis rotary platter.
You can come up, Tyler.
Sure. From the UMC 750, so it's 500 millimeter diameter T-slot platter, 19.7 inches. And then over here we have a stationary table that's 32 inches long and 18 inches wide, a couple of T-slots. The table is stationary and the head moves back and forth. Essentially this machine is a UMC 750 with the stationary table and extended X-axis travel.
So it's like a VF1 or a VF2 and a UMC 750 kind of morphed together.
Yeah, actually looking at the travels, more like a VF2 YT.
Got it. Now, real quick, I see it looks like the platter and the table are on the same height. Is that true?
Yes, they are. They are. So you could fixture a long part across both the platter and the table, and then use the entire 60 inches of X-axis travel.
Now, if I rotate 90 degrees in the B-axis, where is my center of rotation relative to the table?
My center of rotation is going to be 2 inches above the surface of the table.
Okay,
so I have to keep that in mind if I'm going to hold something with a tailstock that's in the road.
Right, so that's what I was getting at. If you're going to rotate 90 and use this as a rotary, like on a traditional 3-axis mill, you need some sort of supporter tailstock.
And because there's assembly tolerance, it's not going to be exactly 2 inches, but that's in the ballpark.
Okay, good. So, features of this machine. I noticed that the doors are on the inside, which is much like the redesigned UMC 750.
Yes, exactly like the redesigned UMCs. Doors mounted inside, and we'll give people a look at this door, right? It's a double sliding door. If you're working on a part that's just on the rotary table, you only need to open it this much, no problem. Right. If you need access to the stationary table, of course you've got to open the door all the way. But the fact that the doors are mounted inside the enclosure means that we could bring the pendant mounting from the side of the machine around to the front of the machine. So you've got all of your operator conveniences right next to the door opening. It's very nice, which also allowed us to move the tool rack, work table, and washdown hose to the front of the machine like
so everything's
almost every other
operator's fingertips.
Yep.
Okay, so obviously this is a new machine, kind of a combination for us. Who want this machine? What is the target shop?
In my opinion, the target is a job shop. Somebody who's doing a different setup every day. One day you're doing 5-axis parts, the next day you're doing 3-axis parts. Or maybe you've got several different jobs that you want to leave set up on your machine because you're doing them every couple of weeks or whatever. This is perfect for that. You can work on the rotary table all day long and leave this sitting here no problem, and then just call a program that jumps over here and machines parts. It's a fantastic, versatile machine. There's hundreds of ways to utilize this machine. And as a matter of fact, not only do we have a place for work holding here on the stationary table and the rotary table, but like all of the UMCs now, we have a
there we go.
Sorry, I got to be careful about that door not opening right away. We have a machined area where work holding can be mounted here on the side. In this case, I've got a vise with a workpiece, and I could do another setup over here on the side of the machine. So
let's say, for example,
really
you've got
versatile.
a dovetail vise here.
Exactly.
You could cut your dovetail here, or you could cut the dovetail off.
Yeah, okay. Perfect. And to give people the idea of the size of this machine, if you're familiar with Haas products, it's about 3 inches shorter than a standard VF5 and about 13 inches deeper than a standard VF6. So that'll give you an idea of the footprint for your shop, and you get a tremendous amount of machining capability with this machine.
Okay. Now let's talk a little bit about machine construction. It's very similar to UMC, but obviously it's much wider. Can we come around, Tyler? You want to come around to the back of the machine? You can talk a little bit about the design. We'll have all this crap moved out of the way tomorrow, I hope. Okay, so now we can see the castings, obviously very unique looking here.
Yeah. So the arch design of the bridge, which is the x-axis of the machine, a single arch on a UMC 750 gives us 30 inches of travel. This machine has 60 inches of travel, so we just extended it, put a double arch design on it, and works perfectly. You can see the base of the machine is extended.
Yep.
What we need to support the bridge. Over here you've got the 4th axis rotary products for the B axis, brake reservoirs for the hydraulic brakes up here, saddle mounting, Y axis, and then Z axis mounted on the front of the ram.
Cool. It's nice to be able to see the bones of the machine. Most customers don't get to see this. Great. Okay, well, let's go back around to the front. Tyler, if you can do that without tripping over everything. We got to get this cleaned up for sure. Wait for him to get set back up there. All right. Have a demo ready for the a little difficult to see because obviously we need to. But what we'd like to do, and I didn't mention at the beginning, is if you're watching on YouTube or through the website haascnc.com, we have a chat feature enabled. So if you have any questions or comments, please type your question or comment into the chat. And while we're watching and talking about the demo, we'll try to answer them as best we can. So we're going to close the doors and let's get started.
Yeah.
Come on up, Tyler, yeah. And Corey, if you have any questions, we'll take them while this is running. Okay, so what's the part we're machining here? So here's a question. This comes from Frank R. And I think Frank R. might live in Ventura, California, if I'm not mistaken. Can I get 2 platters instead of a platter and a table?
No.
Yeah, that was an easy one. No, the answer is no. This is the configuration. Now what we do have, we have a blank platter option. So no T-slots. It's a blank slate, so if you want to drill holes, put your own bolt pattern in it, that is an option on the machine.
Not currently on the price list.
It's getting added June 1st. Yeah,
Which was yesterday.
supposedly. So I noticed, John, here on the side of the machine, there's a large side window,
Yes.
which I neglected to cover earlier.
Since we moved the pendant around to the front of the machine, it allowed us to put that larger side window that slides up for easy access to the machine. You get access to the rotary platter, as well as it's actually a really good place to clean the machine from. And then again, if you want to add some automation in the future, all you have to do is add a pneumatic cylinder to that window for raise and lower, put a switch on there, and
Perfect. So if we want to do robot loading, or even in the future APL auto parts
Yes.
loader, that's a perfect spot to do it. Let's talk about some of the standard and optional features on this machine. So
Okay.
standard spindle is what?
So the standard spindle is 8100 RPM, but
Okay.
this machine is an SS version.
Okay.
So the standard spindle on this machine is 12,000 RPM
Got it.
with an option for 15, and you can get the HSK 15,000 if you want.
Okay, so there is HSK option on this
Yes.
machine. Okay.
The high-speed tool changer, high-speed rapids, and high-speed spindle come on the SS version, as well as high-speed machining option included with the price. As with all of our dedicated 5-axis machines, dynamic work offsets and tool center point control are standard. The probing system is
I
standard.
was just going to ask.
Yeah,
Yep.
absolutely. It comes also with BPS templates to help you program probing routines, and also to find the machine rotary zero points, which is critical to keeping your machine running accurate.
Great. Hey Tyler, you want to come around to the side and let's see if that's any better as far as seeing the demo. We won't do this tomorrow, but that's probably no better, is it? That might even be worse. Okay. All right.
I would not ask me what the demo part is, because
Okay.
essentially it's a
Okay, let me, we would have more questions, but at this point, thanks, John.
Yeah.
Appreciate you
Thank
showing
you.
me this.
My pleasure.
We will take this demo and use some GoPros and get a really nice demo video, and we'll post that on YouTube in the coming weeks. I know it's hard to see with the doors closed and all the cooling. So that's it from the UMC 1500 Duo. Let's throw it over to Andrew Harnett and Bob Singh at the ST20 and the APL. Take it, Andrew.
The machine's already running here because we started a little too early, apparently. Anyway, why don't we just watch this first and then we'll talk about it.
Yeah, the APL gripper, it's loading up the raw stock. It's just unloaded the finished part. It's now clearing the part and going back to the table to unload the completed part and pick up another raw stock.
Right. So as it comes over here, I'm going to just stop this right here. Now let's say I'm a walker through the shop and I don't know what this machine is, but I get curious. If I walk in here and I break this light curtain beam here, then this protects
The light can, yes, it'll stop the APL motion for safety reasons.
Right. So now that we started it kind of in a weird sequence, let me do a little introduction here. I'm Andrew Harnett. I work in the marketing department here at Haas, and this is Bob Singh. He's a product specialist, deals with all things lathes, and of course, we're demonstrating the automatic parts loader today as it's hooked up to this ST15Y. Now you just saw to unload the part, so it's about to drop the part off here, but let's talk about the templates here for a minute.
Well, we can show that we stopped it with a light curtain. If I
Oh, that's
press
right.
cycle
Yeah,
start,
let's start back up.
it continues, it doesn't lose position, the machine does continue to run. When the light curtain is activated, should we stop it again and we can have a look at
Yeah.
the table?
And another thing to mention is, even if you stop the APL motion with the light curtain, the machine keeps running, right?
Correct, yes. It's not going to disturb that, the door is closed, so safety-wise, that can still run.
Right.
That's a cool feature.
Yeah. Okay, so let's talk about these templates here.
Yeah, there's 3 different sizes, small, medium, and large, and depending on the size of your slug, you choose the correct template. Currently, we are running a 3-inch diameter part, so we're using the medium template, which ranges from roughly 2 inches to 4 inches.
And you've got some, I can see here, you've got some adjustment built into this,
There's a top
two-stage thing.
Yeah, there's a top template that you can adjust. So as you can see, there's about 1/8 of an inch around here. I can place this anywhere in that area, and it's going to pick up the part.
Right, and you decide how close you want to constrain this location
Yeah,
here.
you can adjust the top template to however you desire.
Right.
Yes.
If you got some really gnarly, hot rolled stock or something, you could widen that out, or maybe you've got really tightly controlled stock, you could bring it in narrower. But you have enough range here to grip the kind of whatever part you're going for, right?
Yeah, and speaking of the grippers, to set the grippers is so easy, but it's basically eyeball, and you can see it clears when it's unclamped, and as it's clamping, there's a large range for clamping. It'll pick up the part.
Right. We'll see that clamping here in a second. Yeah, but you typically have plenty of room to grab the part. But you can also make custom grippers for this thing if you want, right?
You can make custom grippers for the templates and for the grippers as well,
Right.
depending if you have irregular parts that Haas templates don't, require.
Cool. Okay. So let's head over to the control.
Yeah.
And so right now the machine is in what we call APL mode. That's basically the automatic mode that it runs in while it's running together with the program in the machine. But we're going to take it out of that APL mode now, and we're going to show you how we program the locations on the machine.
Yeah, there's 4 templates. There's 4 tabs.
Four
There's
tabs,
templates. There's load part, unload part, a run job. So we're going to go to the first template and just go through a series of questions. Like the first one is part type. Are we running slugs or are we running bars? Just enter the information. As you go down here, you'll fill it out slowly. As you can see, the next one is number of rows. And the animation shows exactly what it's asking for.
Right. In each case, it's quite helpful here. You can see there's a descriptor line for what you need to enter on that line, but then there's also these animations which make it pretty easy to figure out what you need to do to enter each particular value.
Yeah. And right now we've already entered the distance between rows and distance between
so
columns.
As Bob was mentioning, the machine comes with these 3 templates, and there are corresponding programs already in the machine that correspond to those 3 templates. So if you have one of the ones that's provided by Haas, then it already has all the distances and everything entered. But if you make your own custom one, then you can enter those distances there.
Yes, you can enter anything you want over here, as long it'll just keep accumulating and pick up the right slug at the right parts.
Right. Okay, so that brings us to the load part tab, right?
Yeah. So shall we show them how
let's
to load
reset
it?
this so we can
Okay.
get out of APL mode and show setting a position.
Okay, I'll reset this. Get this table reloaded.
Yeah, so now we're taking it out of automatic mode, so we're going to just place all raw slugs here so that we can bring the gripper down and align where we're going to pick the part up from, because that's the first step that you do. So what did you push right there? So okay, so you're
That was
resetting.
just resetting the table, so I'll just put it in recover mode just to go back to the home position.
Right. And then you're going to show, so there's a bunch of neat features on here. One of the ones that Bob will show us in a second here is there are some single button push moves that will take you from, let's say you're over here on the bridge above the door, but you want to come back here to program your pickup location. It's a 1 button push to take it all the way over instead of doing all the jogging. So
yeah, if you can see the animation now, we're on the first instruction that we're supposed to be doing, and which is initial pickup. So the graphics show you need to manually jog the APL gripper above the part. Now I could do that manually with the jog handle, or there's a cool feature here, insert to move above table. I could just press this insert,
right,
and it'll wrap it to above the part so I can continue.
Right, so even if you're all the way over there, it's going to bring you over quickly. And so from here, you're going to jog to get in close. And you can also do that same move from the remote jog handle as well.
And you can see I'm so far away from the control is so far away from the APL. We're going to use the jog handle, the new jog handle. It's a touchscreen. You can pretty much do most of the setup with this.
Yeah,
instead of walking all over.
Let's see if the camera can see it. So all you do right now to select a different axis of movement is
select an axis, just pick the axis you want,
touch it.
the speed you want to go at, and you're in jog mode.
Quite a bit easier than the previous jog handle.
Okay, so as the animation did show, we have to walk this over to above the part. So I'm going to do that while you...
I'm going to get out of your way.
Yes. And as you can see, it's all eyeball.
That's right. And in each case, eyeballing is enough, and it makes it pretty easy to do the alignment steps. So you're just moving down. So we've got 3 axes, of course. AW is up and down. AU is back and forth across the bridge, and AV moves the table back and forth. And now you can also, besides jogging the axes with the remote jog handle, you can also actuate the clamps and do a bunch of other stuff.
You can flip the gripper, you can clamp and unclamp. There's a lot of features you can do here, right? So I'm pretty happy with that position. I'm going to check that position. So with the jog handle, the clamp right there, as you can see the part slightly moved, but it's still in the range. I'm happy with that. So I'm going to capture that position.
Right, you're pretty much even side to side.
Yeah.
And if you want, you can jog AU and AV back and forth actually in this grip mode just to fine tune where you are
exactly,
as it is gripped, and then set it there.
Yeah, so I'm happy with that position. And now there's 2 ways of capturing this. There's no programming involved. There's no calculations involved. It's I can press record on the jog handle, or I can walk over to the control and press F2.
Right.
So if I press this right now, you'll see the numbers on the control have changed, and they've captured that position.
That's it. So
that's it for the first bit. I'm just going to walk this.
And that's essentially what you do with all of the positions that you record. You get the grippers where you want, and you press record on the remote jog handle or F2 on the machine. All right, so now you're going to return it over to above the door, right?
Yeah, so the next animation shows that we need to go to the ready location. We can, as the animation shows, go all the way up, manually jog it, flip the gripper, and then manually jog it all the way across here. Or we can use this other cool feature. Yes, takes forever. So, we could just press insert and let the APL run through that motion for us. Saves a lot of time. It's just so
now it's
quicker.
rotated to put the raw slug into the load position.
Correct. Now it's taken us somewhere that we need to be. I'm still not happy with it because I know that when it does come down, it will hit the sheet metal. So I will adjust this ready location slightly.
Right, and you're basically
I'm just eyeballing
it between this point and this point here. The face of your chuck and the edge of your sheet metal here to have your clearance coming down.
Correct. I'm pretty happy with that position. I know the ram is going to clear the sheet metal. It's going to clear everything else. So I'm just going to press F2 and capture that position. As you see, the numbers changed again, and it does say ready location is set.
Cool. All right. So then, okay, so you're good there. What's the next line after this? This is kind of an important one.
The next one is the safety one. It's the safe axis location for load. This can easily come down, but as you can see, it will hit the turret. So there is a safe axis we can go to.
This basically sets all of the positions of the axes and the position, the tool number that the turret's set to in order to give you the correct clearance as the arm's coming down.
Yeah.
So it's kind of the machine side of the interaction here.
Yeah, as the animation shows, it's going to hit right now on the turret, so move your X, Y, and your Z clear, and to a correct tool location. Now, I know my tool location is tool number 7, so I'll index over to tool number 7. Manually jog this clear in X and Z and Y. I pretty much know that position is clear for the APL to come down and load and unload. And there's
you've
3 positions.
You've checked that already, but typically you're going to bring the arm down.
Yes.
And you're eyeballing it whether or not it's going to hit anywhere. And generally, particularly on a smaller lathe like this, you're going to want Y-axis back all the way back away from the position of the arm. Yeah. Otherwise, you're gonna run into it.
Yeah. Now I've just moved 3 axes and I've indexed to a certain station. I don't have to do any programming again. I don't have to do any calculations. Press F2, and it has captured that part, and it will go to that position, safe area when it's loading and unloading in the APL mode.
Cool. All right. So let's talk about I guess let's just keep working through the screen here. We're not going to demonstrate any more motion because it's pretty much the same throughout, throughout all the programming. But let's just step through the screens quickly here so they can see all of it.
Chuck load location, obviously, looking at the animation, bring it down in W, go across in U, capture that position.
Yeah, so there you're going to bring the part all the way into the, like in this case, the stop on the hard jaws, right?
Correct.
Or the stop on the soft jaws.
That's it for loading. And then
Right.
the next thing you do is go over to unload. So easy. Similar questions, positions, 3 positions, unload, where you want to flip, and where you want to drop off the part.
Right. So yeah, where you're gonna grip it to unload it, and then particularly you're gonna tell it where to flip the part at.
Yeah, as you saw at the beginning of the demonstration, it flipped in the machine so much quicker, so much time saved.
You can, if let's say you have a really large tools or a longer part or something, I suppose, you can bring it all the way up here to do the flip as well if you want to.
Yeah, there's 3 positions in the machine, above the machine, or above the APL table.
Right. Alrighty, so then let's move on to the final page here.
This is run job. Basically, it'll tell you how many parts you have run, what your next part is, how many parts you've completed. You save your jobs here, and this is also where you press insert, it will set up the APL.
Right, this is where you
mode.
actually turn on APL mode.
Yes.
So you're telling it, so you can tell it if you don't want to run an entire table worth of parts. Let's say you've got 24 spots on here programmed into your particular APL
Correct.
program. If you want to just run 4 parts or 12 parts, you can program that on this
You go to the
screen.
run mode tab and you select 10 pieces if you want that sound.
And it'll keep track of that for you. You can even run multiple loads. It can continue the job through multiple loads on the table. And then, but like you were saying, this is also where you turn the APL on to APL mode, so it works in the automatic. It works automatically with the part program.
That's right. Yes.
And that's pretty much
That's
it, right?
Yeah. So easy.
Cool. All right. So I think I'm just going to hang on to these questions I have here so far, and we'll answer them after we get done talking about the mill APL with Milton Ramirez here. He's doing the quick handoff of the audio receiver here. All right, let's head over. About a 10-foot walk. Let Sal get situated here in his camera. All righty. So this is Milton Ramirez, another product specialist here at Haas. And lo and behold, the automatic parts loader as we have it connected up to this VF2. So once again, we're doing pretty much the same kind of idea here.
Mm-hmm. So I just finished setting up my part here. This is a part, just a typical, machine part, very simple with an OD contour, a pocket, some threading or tapping and drilling. It's a part that takes about 2.5 minutes, and I'm ready to run it if you want me to go for it.
We're going to do some loading and some little tiny bit of machining and some unloading.
So
watch the whole
before I run it,
process.
just real quick, my part program is completely independent from the APL itself, right? So I can run my part normally like I would with a machine that doesn't have an APL, but when I'm ready, I can just go ahead and go to my current commands page and go to the devices tab and the APL tab. And then at that point I can press insert, just like Bob did over there, and now you're in APL mode. So at this point, I have my table set up with all my parts. My part program I know is proven and it's ready to go. I have an M299 at the end of the part program, which is really just the same as an M30,
Same as M30,
M01,
except
but
it's
if it has an
prompting the
APL, then
APL.
it prompts the APL to do its thing, right?
Right.
So we're ready to go, and we'll push cycle start.
Let's do it.
All right. So the machine itself, sorry, I think I wasn't in memory mode.
There we go.
So it's going to load the first blank, basically. It's a really fast loading cycle. It's about 30 seconds, I would suppose, about 30, 35. The dwells, you can change the dwells on the control, which are the time it takes between dropping it into the vise, clamping the part, unclamping the part, and then getting out of there, right? You can control how fast that is done. It can take longer if you want. It's just, you know, a safe time that we're taking to make sure you're clamping the part correctly, right? Once it gets out of there, the APL does its thing. As you can see, it immediately goes and grabs part number 2 as the machine is running. I'm going to show you something real quick here. I pressed feed hold, but I did something not by mistake, but so that we can show you guys. As I was washing down the machine, I forgot to open the coolant nozzle. So I'm going to do that now. I'm going to have to hit reset. Okay. Open the coolant nozzle. I'm going to go back to memory mode. I'm still in APL mode. And the program started over again because I didn't put it in the first tool. I could have started on the second tool, the third tool, the fourth, any tool, it didn't matter. The machine lets me interrupt, lets me recover, it lets me do a lot of different things without having to actually restart the whole part, okay?
Right, so the APL itself is still essentially in the same place it was in terms of how what it's doing.
Exactly, and that's because it keeps count of what part is loaded, what part is ready to load, and you know, it knows where it's at all times, okay? So this is gonna take about 2.5 minutes, and I was doing the math, and let's say, for example, if you have a 3x3 part like we do over here, you're gonna be able to put 60 parts on the table. If it's 2.5 minutes each, that's about 2.5 hours of machining time alone. The APL is gonna take about 30 minutes to load and unload those 60 parts. So overall, it's 3 hours to machine 60 of these parts unattended. Those 3 hours, like you were saying, Andrew, over there,
yeah, 3 hours
with Bob,
you can do, your operator could do something else completely.
that's a long time.
Right.
That's almost half a day, basically.
Right. So we have a question here about, you know, at what point is the APL going to be going to hold up my operations? Is there a minimum cycle time that might hold you up at some point?
I was timing this APL a little while ago, and it's about 35 to 40 seconds on average to load and unload a part. So I would say if your part is faster than that, then it might wait on the APL. But if it's not faster than 40
so you
seconds,
have to have a very short cycle time in order to be waiting on the APL.
Exactly.
And it still doesn't mean that you're not running unattended. It just means that it still might be in motion while you're finishing that off.
It would mean the APL is taking more of your time than the machining.
Right.
But again, it has to be a 30-second, 40-second cycle time.
Right, and your operator is still not standing there in front of the machine.
That's right.
It's still doing its thing on its own.
That's right. So that's the whole thing behind the APL is automation, running unattended, running lights out. If you have a couple of these, like I know a customer that has a couple of these in Texas that, you know, loads up the tables, has an APL in the mill, and walks away, goes out of the shop for 4 to 5 hours. When he comes back, he has table loads of parts, you know, that are finished. So, I mean, that's probably not the ideal thing to do, to leave the shop, but, you know, because you can do a lot more other
Maybe
work.
Doing something else.
Exactly.
Yeah. Hey, if you want to do
you know,
that,
yeah, if you have something to do, that's okay too.
We have a question that came in here. Can I use my own custom vise or vacuum table on this mill APL?
So I'll answer that right now. I just want us to focus
first
on this part over here. So unloading the finished part. It's going to air blast. So just for safety reasons, we get out of the machine, close the doors, air blast the jaws so they're clean and free of chips, and then go in again and load the slug or the blank. So out we
that's
go.
that dwell you've talked about.
Those
there.
are the dwells. They're about
so you
set
can
up.
reduce those as you become comfortable that your setup is good
Correct.
to go.
That's correct. Yep.
Error free, I guess you'd say.
Yeah. Exactly. So, as you notice, you know, just like the lathe APL, I can interrupt the APL motion with the curtain here if I want to approach it for whatever reason. If I need to look at something up close, I know that I'm safe. The APL is going to stop. I can come over here, look up at my part, and nothing's going to happen, right?
And at the same time, interrupting this doesn't affect what's happening inside the machine.
That's a very good point. It only stops the external motion of the APL, but the mill itself keeps working and doesn't stop.
Right.
So I can just resume again, right? By pressing cycle start.
Okay, so back to this Well,
Oh, sorry. Yeah,
so
the
back to this
question.
question, can I use my own custom vise or vacuum table on the mill APL?
That's a very good question. Yes, I don't know if you guys were able to catch it when Sal was with the camera looking at the demo, but we have a pneumatic vise in this case, and it's an industry standard kind of available vise off the shelf, right? That we got. I don't want to say the brand, but you know, they're not paying us to promote it, so.
Right. Let's just say that, right?
Exactly. So anyway, it's a vise that you can buy off the shelf, and you know, the APL comes with air provisions for not only to blow off the jaws off the chips off the vise, but also to actuate the vise with
Right. And there are also, well, I will get to that probably in a minute, but there are also controls in the control software to
that's correct.
control an automatic vise.
That's correct. You can open it, close it, you know, adjust it, and everything else.
I'm wondering now why we're running our second part.
Yeah, exactly. Yeah, we'll stop it.
Yeah, we'll stop that in a minute here. So
I'll set up.
So we got
optional
another
stop.
one, another good question here. Does the mill APL come with stock templates like the lathe?
The mill APL, because you know on the lathe most of the time, or probably all the time, they're going to be round parts, so it's easy to predict what's going to be run on it. On a mill, it's kind of difficult. It could be odd-shaped parts, it could be long, they could be rectangular.
Right.
So because of that, we don't really supply a template at this point. But you know, any simple, you know, custom-made template would do. What we're really looking for there is basically just a setup point or a stop point for every part that's repeatable, right? So even a simple pegboard would work.
Right.
You know, putting a pegboard up there that's equally spaced, so you can put your parts up against the stop, right? In X and Y, or in this case in AU and you know, AW, and that would work.
Yeah.
Okay.
Did you want to go through some of the templates a little bit closer?
Yes, yeah, we'll do that. Yeah.
Yeah, we're just taking our time.
Okay, no problem. And that's you, right? They're gonna
How much time?
They're going to go to
Still.
Oh, I think, yeah, we'll do a little bit. Let's just quickly jump through the templates, and then we'll throw it back over to Brian.
Okay. All right.
Cool. Well, that's kind of covering the mechanical side of it. Let's look at how you program this thing. It's pretty similar to how you do it on lathe. In fact, if you have a lathe APL already, this thing is going to be a dawdle. They say that, a dawdle? A dawdle. Something like that. Anyway,
That's correct.
Let's jump into it.
So you guys can see there on your screen, I'm sure you're looking at the screen right now. So that's the first template that we have on the APL mill. And it's pretty much exactly the same as the APL lathe, right? It's looking at the part type that I'm picking up. You know, it could be a rectangular, it could be a square part. And your fingers or grippers are supposed to be at this point already adjusted for that, right? And so we define the part, and then the number of rows on your template, right? Rows are from over the table from front to back, and the GIFs are really helpful for that because, I mean, most of the time we don't memorize which is the column, which is the row, right?
Exactly, right.
So the GIF will tell you exactly what we mean by column. So columns, and so you, based on your template, you're going to enter the numbers of columns you have here, and then the distance between them, right? The distance between each row, the distance between each column, and again, they have to be consistent. They have to be the same between each one of them, right?
Those distances can be different on the rows and columns, but they have to be
the same between each one of them.
Yeah, like all the row columns have to be the same separation, and all the column separations have to be the same as well.
Exactly. Okay, so pretty much just 5 questions here, and we're done with the template, which is the setup here on the table, right? The next one would be the load part tab, which basically has, you know, the definition of OD gripping or ID gripping. You can grab this part from the inside. Any feature, if it was a casting that already had a hole, you can grab it from inside, or you can grab it from the outside if it's just a slug. So on the first line, that would be your OD, ID. Then that's the delays we've been talking about between the time you release the part or grip it. Initial pickup location. This is basically just talking about the first part on the table. You're going to handle jog the APL, right, with the remote jog handle, which is included with the APL. And you're going to move around by hand until your grippers pick up the part like Bob was saying, not exactly positioned. They don't have to be perfect, but I would say between 30 thou maybe.
You're going to get it as close as you can, eyeball-wise, but that's
30, 50 thou
close
would
enough,
still work, because the range here on these grippers, open and close range, is 1/2 an inch per side. So you have a lot of room to play with there.
Right.
Okay, so all right, so then you jog over the table. The ready location is a location that's already right above the chuck or the vise, right? And then the internal access location for load, that's the only one that's different from the APL, because this defines the X and Y location on the table, right? Because you have to move the table to where your vise is. Your vise could be anywhere on the mill table. So this is going to define your X and Y location, your Z location as well as the even. Because if you have a large, long tool, it might interfere with the APL when it comes in.
You're going to get that out of there before
So you want to make sure you have an empty pocket maybe, or a tool that's really small and short. So that defines that. And then your vise load location, which is now the APL dropping off the part on the vise itself, right? Once you jog to each one of those positions, all you have to do is press F2 to record it, right? F2 automatically inputs the current access location into these rows. So no number entering.
Right, you're not going to fumble finger something and mess up the
no
location.
adding.
It's just press the button and whatever your location is at that point gets entered in.
It'll record it there. So really easy, almost error-free, right? The alignment, that's
the only errors you get are your mispositioning
your own.
if you visualized it
Exactly,
incorrectly.
exactly. Other than that, it's really easy to enter the data, right? Alignment is basically just moving up the Z position, you're clearing the jaws, and you're ready to go, and that's what you record
It's essentially
on
your
that part.
exit point
Yes.
after you've loaded the part.
After you loaded the part, yeah. And that would be the first tab already, right? And then you just navigate to the unload part, and that's going to be pretty much the same thing we just did on the table in reverse.
Right, and the same thing we did in the lathe. Basically, now you're just reversing the operations to take the part out and put it back on the table.
Exactly. This time the difference is you're not going to use gripper number 1 for removing the part from the vise. You're going to use gripper number 2. So that's the only thing you have to remember. So approach the part with gripper number 2. Do your adjustments again with the remote jog handle. Just visually, pretty much locate yourself where you think you're right on center of that part, and proceed
maybe you're gripping on the ID of the part here versus the OD. If you came in on the OD, but now you've machined off a place that's good to grip. So maybe now you're gripping an inside feature. I mean,
exactly. The nice part about that is that I can get my face in here when I'm doing that, right? And I can also open and close my grippers like I'm doing right now. As you can see, this opens and closes grippers number 2. This opens and closes gripper number 1, right? Gripper number 1, and
that definitely works.
Yeah. So when you're adjusting your part on the vise, you can open and close the grippers to actually see how it's going to grip, and if you're happy with that. Once you do that, then again you press F2, and it records the values. Again, these values are pretty much a repeat of the first tab, just in reverse, and then pretty much the last one is once you grab that part, open the device, get out the APL out of the machine, and go drop it off in the same location where you picked it up, right? So you're going to program that drop-off location. We recommend staying away from the table in height about 100 thou and just dropping the part, right? Most of the time, nothing's going to happen to it at 100 thou drop,
right?
Right? So
and one of the things I guess we didn't really mention on the lathe is that the only position you're programming in terms of your interaction with the table is position number 1.
Yeah.
And that's the beauty of it. That it calculates every other position based on that, just based on what pocket separation you've defined on the template. Region.
That's correct. That's correct. So this machine, it's a beauty. I think it's faster than the lathe because it travels a lot less, right? It's right in front of the machine, so that's why it's down to 30 seconds of load and unload time.
Right. Mm-hmm. You don't have the part flip in there either.
Exactly. So that pretty much completes the unload part tab, and then you have your last one, which is the run job. This is where you can enter and exit APL mode, as you can see on the screen. APL mode in, APL mode out. You also have your counters. I had already made 2 parts. When I'm done with the table and I want to start over, I can just reset that to 0. I can go down to the completed parts and press origin. It'll ask me if I'm sure I want to do that. If I do, then that tells the APL that I'm starting a completely new table, right? I'm starting over from scratch. So that's basically the most important part, and we have a couple of other things that you can do on this screen. For example, you can set the APL rapid override to 75% if you're comfortable with
when
running
you're setting
slower.
up the machine, you can slow things down
Exactly.
until you're sure that all your pickup positions are correct.
You can run it at any speed or any rapid override that you want, right? Also, right below that is a slow rapid distance that right when you're going to come down to pick up the part, if you wanted to slow down 100 millimeters or 4 inches above the part, you can do that. So we have it set at 4 inches above the part, and then you can do that at 10% rapid. So you're rapiding down, stop 4 inches above, and then you go really slow to pick up the part, right? That all depends on how comfortable you are with what you're doing here and how easy your part is to pick up, right? And then the last line here on the Run Job tab just tells you the current state of the APL at any given point, right? If it's gripping the part, if it's ready to load, if it's ready to unload, or whatever state the APL is, that'll let you know what it is. And then that's about it.
That's about it.
So I guess one last thing that I'd like to say is, I don't know if we're almost done, but
well, we'll answer some questions here in a second, but yeah, go for it.
once you're familiar with setting up the APL, it doesn't take more than 10 minutes to enter your information for a new part and create 10 to 15 minutes to create a new program and save it. You can save all your different APL programs. We recommend naming the APL program the same as your APL of your part program, so you can always run them in conjunction,
it's easy to
right?
tell which ones you're marrying up.
Exactly. You can even add notes to your part program to know which APL program runs that particular part, right? And you can save different grippers and just have a whole automated process in your shop.
Yeah, and once you have, I've found that once you have a number of programs in there, often the values, many of the load and unload values are going to be very similar or exactly the same from program to program. So a lot of the information can carry over. You can load one program and then just essentially modify the sections that are different in that case, but much of it can carry over if you're starting from an already established program.
Yep, that is correct. Yeah.
So we have some different questions here. A couple of these came in on the chat, and then some more came in via email earlier. Can I adjust the part? Do I need to, and can I adjust the part? The grip pressure on the grippers here if I have very, very delicate parts.
Yeah, that's a good question. It comes up often sometimes when customers have thin-walled parts and they don't want to squeeze too hard on it. For now, we don't have any pressure adjustment on the grippers. So, right now it is what it is. We work with 110 PSI, but if a customer found a way to minimize that
you could
PSI
regulate that down.
With regulating it, then they could control it, but it would have to be done after the fact.
And the weight of the part that we can pick up right now with this is?
Currently is 10 pounds.
Right, so pretty good sized part. But the grip pressure isn't exceedingly large.
No.
You have to have quite a thin wall part.
I can't tell you exactly what the gripping force is right now, but I know that it's not. I mean, we're gripping aluminum with steel grippers, and it doesn't mar the part at all or anything. But it's still capable of picking up 10 pounds.
Can I put an APL on my older Haas lathe?
We do require NGC at a very minimum, right? For a lathe and a mill, you got to have NGC software. So that's at least a year and a half old to be able to run it.
Right. Well, I think that wraps it up here for us. Thanks, Milton, for all the great information, and I'd like to say thank you, Bob, for all the great information he gave us. And now we're going to throw it back over to Brian and Corey, who are at the Haas robot.
Thank you.
And that would be us. So I've made it back to the demo room, and I'm here with Corey Sullivan, product specialist. Now today, or in this station, we're going to talk about the Haas robot package, which you see here. So I've been to a lot of open houses and trade shows and demo days, and when somebody talks robot, the first thing they do is their eyes glaze over and they say it's too expensive and it's too hard to integrate. So we've addressed both of those. To begin with, this unit that you see here is under $50,000. And the integration couldn't be easier. How do you integrate this robot with the Haas machine?
Yeah, so it's a pretty simple process. You just plug the robot in. Once the machine's plugged in as well, you just have an Ethernet cable that goes in, connects to the robot, and connects to the machine, and
So that's it? It's literally just an Ethernet cable?
Yeah, the machine and the robot will talk to each other through a protocol.
Okay, so in the past, when you think robot, you think integrator, you think a lot of work, maybe bringing somebody in from the outside. That's no longer the case here. We've worked with Fanuc. All the software with the robot is designed to work and integrate directly with the Haas machine. So everything you do is directly from the Haas control. So you and your HFO can set this thing up. There's no third party involved. Okay, so connecting it is easy.
Yeah.
You plug it in. Now, how does the machine know the robot's actually connected?
So you would come over to the robot tab.
Okay, so we're using VPS templates just like we did on the APL.
Very similar style. It's pretty easy to use. See, there's a prompt that says F1 for setup options.
Yep.
And it'll have to be an e-stop to connect.
Okay.
And you just press the connect button.
So you follow the instructions, basically.
Yeah, and you can see on the screen right here, right below that GIF, it'll say connected now.
Okay.
So
it's as easy as that. You plug it in, you go to the connect tab, and
yeah.
press enter.
Yep. And so
Okay.
actually now I could pick up the touch remote jog handle, and if I'm in jog mode, I can
Okay, so now
start moving it.
you're going to jog it just like you would a machine axis?
Yeah. So it has two methods for movement on the robot. The first is linear mode, we call it. It's just like what you're used to on a mill. You know, you have your X, which moves basically left to right.
Okay.
Your Y, which will move essentially backwards and forwards. Which
Okay.
is this one. And then Z, which will do straight up and down, just like on a 3-axis mill.
Okay, that's easy to remember.
Yeah, very easy. So then the other mode is joint mode. Or I guess before I move on, I should note there are W, P, and R, which is rotations around those axes as well. So W will rotate around X, like this. And then
Okay.
P will rotate around Y, and R will rotate around
Z. Okay,
One
it's
of the
easy enough.
First things you'll do before you start moving in this motion, though, is the default will be set to the base of the robot. And if you can see, our robot is mounted at 30 degrees.
So okay, so the base of the robot, not here, but this base.
Yeah, right here.
Okay,
And so your default Y and Z will be set to that plane. So it'll go Y and Z would come this way.
okay.
It's pretty easy to do, to set up your own frame, and you can set up multiple frames.
So a frame is what tells the robot
Yeah.
where the parts are?
Basically, it's a lot called a coordinate system a lot of other times.
Okay, that makes
So,
sense.
Yeah, it just, we want to set our X parallel to the table, and Y, and then Z also.
Okay, so the first thing you're going to do is you're going to teach the robot where the parts are.
Yeah,
It's not on a 30-degree plane, actually.
Yeah.
We need to let it know that it's on a flat plane.
exactly.
Okay,
And so the way you do that, we call it the three-point method.
okay,
You'll basically just jog it down, touch the table, set it kind of like you would set any other tool. And you could use a piece of paper if you want to get that perfect.
Okay.
And then you would go set that point. You'd move over an X to set your second point, because this would just connect the two dots and make that your X.
okay,
You'd go back down to whatever Z level you were at, so you don't make your X at a slope, and you'd touch there, set that point, and then you need to move in Y, and you want that to be exactly in Y to your plane, so ours will go up in 30,
yep.
you come back down in 30 till you touch the table the same way, set that with a piece of paper, set that point, and you're good to go.
So you've taught the robot 1, 2, 3 points, and they're all on this flat plane.
Yeah.
So that's how it knows where the parts are.
Yep.
Okay,
Yeah.
simple enough. And you've already done that,
I've
obviously.
already done that for this one,
Okay.
for this presentation, so. Yeah, we'll go on to the second method then. The second method for moving is joints, and that's, you can control each individual joint, which is more
Okay.
standard to robot control. So you got like joint 1, which is that very bottom one. There's 6 joints on this robot.
Okay,
So joint 1, you see rotates just that joint. Everything else stays the same. And then you got 2, which is the next one up here. It just goes 1, 2, 3, and then 4 is that rotational one.
yep.
5 would be the wrist, and then 6 is the rotation of those.
Okay, easy enough. Now you're moving just like you would use the remote jog handle on a miller or lathe. You're just moving through the different axes.
Yeah, it's the touch, so you can just touch up.
Tyler, are you able to zoom in on that a little bit real quick?
So I could just touch one of these, say I want to move joint 3, and
Nice.
now you see
Okay.
joint 3 is moving. It's very easy. Yeah, very simple.
Okay. Thanks, Tyler.
So
Okay, so I'm assuming now, okay, now we know how to jog the robot. This is how we're going to teach the robot where the parts are and how to put the part in the machine.
yeah, so it's very similar to the other 2 APLs that Bob and Milton just showed. So the first tab here is template tab, where won't go into too much detail because it's very similar to the other ones. It's rows, columns, number of stacked parts.
Okay.
So just
And
like the
same
other one.
distance between rows, distance between columns. So it's exactly the same. And the template is
Yeah.
obviously a smaller version of what we just saw in the mill APL.
Yeah. So there's a couple new ones in here for the robot, and that is part flip, because the robot can handle 2-axis operations, and this will disable or enable a 2-axis operation.
Okay.
Basically, you'd have a stand here. We don't have it on this job, so you don't see it here. You'd have a stand, so it'd be able to set the part down, come over to the other side, grab it.
So
load
if
it
you
back.
had a 2-op part, let's say you do some turning on this part
Yeah.
on that stand, then it would come grip it in a different location. Okay.
Yeah.
Makes sense.
That way you can get basically a part, both sides machined and done with just one robot program here.
Okay.
It will allow you to even, when you enable that, it'll enable a couple things, but one of them will be program 1 and program 2 also, so you can have a second program for your
For op
your
2.
first op and your second op.
Okay. Easy enough.
And these mass settings are just used, you don't need to be exact, they're just used for calculations of the robot with movement, so it knows not to damage any of its joints.
So does that control the speed or that dictates the speed that the robot moves to an extent?
To an extent, not exactly. Just
Okay.
you will set the speeds yourself, but it doesn't want to. You can damage the joints if it's holding something too heavy
And
it
moving too fast.
So you just want to make sure you put those in.
Okay. And we should mention, I failed to mention at the beginning, that this robot is a 7-kilo robot, which is about 15 pounds. That's the maximum capacity.
There. Yeah.
Okay. So we've estimated our part size, we've dictated where the raw material is on the template,
Yep.
and now how do we teach the robot how to put it into the machine? Or am I getting ahead of myself here?
No, not exactly. Similar to the other one here, you'd have the initial pickup location just on like on the other APLs.
Okay.
Where you jog down over the part, grab the part, and you just press F2 and it'll record the exact positions of the robot.
Just like the APL?
Yeah.
Okay.
Second one would be moved to a bug table, and this one is also going to be your safety location. So you'll pull the part straight up in Z so that that part and all the rest of the parts will clear the table when it's moving.
Oh, okay.
So it doesn't move straight over and
like your airplane.
take all your other parts out.
Yep.
This is a good position too because it does the recovery mode. So since this is the safety position and I've just jogged that, I can come over here or here, and you'll see it says undo, move to safe position.
Okay.
So what that does is it'll just move it to that safety position that I'd recorded earlier.
So no matter where the robot is, even if it's in the machine.
Yeah.
Okay.
So even if it's in the machine, but the robot and the machine don't necessarily know what each other are, so you'll have to be careful about that. You don't want it to come straight through your machine.
Ah, got it. Okay.
But it's very useful for a few reasons, just for, like I showed you, to get it back to the starting position.
Okay.
Or for, if you've overextended in one way and you need to start over, you can
Okay.
get back there.
And I notice we keep, because we're gesturing inside this area, which you normally wouldn't do, we keep tripping the light curtain. So how does it, and the cage and the light curtain come standard with the robot package,
Yes.
correct?
Yeah.
Okay, the light curtain, how does that affect the robot versus the machine?
So if you trigger the light curtain while the robot is running, just like the APLs, the robot will know to stop. 'Cause
Okay.
The light curtain will shut off the robot. The machine will keep machining though. As
Okay.
long as the door is closed, the machine will keep running.
Okay, good. So you're not affecting your part time and your cycle time?
No.
Okay.
All right.
So you've explained to us the basics of how the robot moves. Can you actually show us, do some
Yeah.
jogging?
So one of the other modes after these recorded positions, just like a lathe APL, you'll see that the next one will be something like this, ready location.
Okay.
And that has a file path associated to it, not a set of coordinates. You can see.
I see that it's got a .xml.
Yeah. So the way you do this is you'll set these up, and instead of just moving to one individual point, you record a series of points, and it'll follow along that series of points in that file.
So that's the file that we're creating is the path that the robot's going to move.
Yes.
Okay.
To do that, you'll come over to the robot tab, and then the recorder tab, and I'll start a new one so you can see a new one real quick here.
Okay, so one for new file.
Yes. So you'll see I can create a new file now. First thing I want to do, you see there's 4 options here.
Yep.
Record position, set speed, APL gripper,
And work holding.
So first one, we're just going to want to set the speed of the robot, which I'll set at 200.
And what's my range there?
We have it maxed at 500 for now.
Okay.
It's at millimeters a second, I should say, too, so it's not just an arbitrary number. It's at 200 millimeters a second. So yeah,
200's a good safe speed for now.
yeah, it's a little slow, but
Okay,
you'll see
we
it's
can bump it up afterwards.
yeah, you can always come back in and edit it to move quicker later. I like to start it a little slower, just in case
Sure.
you mess up.
Yeah, you're
so
doing setup.
We'll do we'll record the first position there just so I can get it back there easily.
Okay, so we'll just call that position 1.
Yes.
And how do you record that?
Yeah, sorry.
That's right.
I just press enter where it says enter a value.
Oh,
Press enter,
okay.
come up, and you just press number 1, which is record
Got it.
position.
Okay, simple.
Yeah.
And then you arrow down and you do it again.
Yeah, so arrow down, it says